Preparing for a mainframe at Kyndryl interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What are the core components of a z/OS mainframe environment? A z/OS environment combines the operating system with specialized subsystems and tools. JES manages job execution and output, SO and ISPF support interactive administration, while SDSF helps operators monitor jobs. Common application subsystems include CICS for transactions and DB2 for relational data. Datasets replace ordinary files in many workflows, and RACF controls access. I would also mention automation, scheduling, logging, and recovery because Kyndryl environments prioritize predictable, secure, continuously available operations. While answering, explain z/OS, JES2 or JES3, SO, ISPF, SDSF, subsystems, datasets, batch processing, online transaction processing, security, monitoring, and how these components support reliable enterprise workloads. Question 2. How would you explain JCL to someone new to mainframes? JCL, or Job Control Language, tells z/OS how to run a program and handle its inputs and outputs. A job statement identifies the work, exec invokes a program or procedure, and DD defines datasets or system resources. DISP controls dataset status and disposal. I use return codes and cond or if/then logic to control subsequent steps. In production, clear naming, reusable procedures, and careful restart design make JCL safer to operate. Make sure to cover job, exec, and DD statements, procedures, datasets, DISP parameters, conditional execution, symbolic parameters, return codes, and practical methods for troubleshooting failed jobs. Question 3. What COBOL features are especially important in mainframe application development? COBOL is valuable because its business-oriented syntax and precise decimal arithmetic fit financial processing. I would explain the divisions, especially data and procedure, along with pick clauses, copybooks, file descriptions, and structured paragraphs. Packed decimal fields improve storage and calculation efficiency. Many applications embed SQL for DB2 access and use CICS commands for transactions. I prioritize clear naming, modular paragraphs, validation, and consistent copybook governance when maintaining COBOL systems. In your answer, discuss divisions, data definitions, picture clauses, copybooks, file handling, sequential processing, embedded SQL, error handling, packed decimal data, and maintainability in large legacy applications. Question 4. How does CICS support online transaction processing? CICS provides fast, concurrent transaction processing for applications such as banking or insurance. A user invokes a transaction identifier, and CICS dispatches the appropriate program within a region. I would use pseudo-conversational design so resources are released while users think, passing state through channels are COMMAREA. Sync points coordinate updates and recovery. Compared with batch, CICS emphasizes low latency, concurrency, controlled locking, and resilient handling of individual transaction failures. Be sure to mention transaction identifiers, regions, pseudo-conversational design, COMMAREA or channels, sync points, task control, recovery, security, response time, and differences between CICS and batch execution. Question 5. How would you troubleshoot a slow DB2 query on z/OS? I begin by reproducing the issue and checking elapsed time, CPU, weights, and recent changes. Then I inspect the explain access path, looking for table scans, poor join order, inefficient predicates, or stale statistics. I review indexes, runstats, package binding, locking, and buffer pool behavior. After changing one factor, I compare metrics against a baseline. The right fix might be an index, rewritten SQL, updated statistics, or reduced contention, not automatically more hardware. Focus on access paths, explain, indexes, statistics, joins, predicates, locking, buffer pools, package plans, runstats, dynamic versus static SQL, and measuring improvements rather than guessing. Question 6. What is the difference between VSAM KSDS, ESDS, and RRDS? KSDS stores records by a unique key, making keyed retrieval and ordered access practical. ESDS preserves insertion order and is useful when records are primarily accessed sequentially or by address. RRDS assigns records relative numbers, supporting predictable slot-based access. All use control intervals and control areas, and performance depends on buffering and free space. I choose the organization based on access patterns, update behavior, growth, and recovery requirements rather than familiarity. Explain key sequenced, entry sequenced, and relative record organizations, access methods, use cases, alternate indexes, control intervals, control areas, and operational considerations such as reorganization and free space. Question 7. How are GDG datasets used in batch processing? A generation data group manages related dataset versions under one logical name. Jobs can reference the current generation with 0, create a new generation with +1, or access previous generations with negative numbers. This supports rolling backups, daily extracts, and controlled retention. I would define limits, catalog generations correctly, and plan restart behavior carefully. GDGs improve traceability, but operators must prevent accidental deletion of generations still needed for recovery. Cover generation data groups, relative and absolute generation names, cataloging, retention limits, rolling files, restart behavior, and why GDGs improve auditability and operational control. Question 8. How do you design restartable and recoverable batch jobs? A restartable job avoids repeating completed work or corrupting outputs after failure. I divide processing into meaningful steps, create checkpoints where appropriate, and use stable input and output conventions. Programs should be idempotent or detect already processed records, while DB2 updates commit at sensible intervals. JCL restart parameters and scheduler dependencies must be documented and tested. I also preserve diagnostic information, because a fast restart is valuable only when operators understand the failure. In your answer, discuss checkpoints, step boundaries, restart parameters, idempotency, temporary datasets, commit frequency, rerun procedures, duplicate prevention, and coordination with schedulers and operations teams. Question 9. How does RACF protect a mainframe environment? RACF centralizes identity and access control across Z/OS resources. Users belong to groups, while profiles protect datasets, transactions, commands, and other resources. Permissions such as read, update, control, or alter should follow least privilege. I would review privileged accounts, logging, password policies, and periodic access recertification. Integration with CICS and DB2 extends protection beyond files. Good administration balances strong controls with operational continuity and produces audit evidence. Mention users, groups, profiles, permits, access levels, dataset and resource protection, least privilege, privileged identities, auditing, password policies, and integration with CICS, DB2, and operational tooling. Question 10. What steps would you take to investigate high CPU usage on Z/OS? I first determine whether CPU growth is isolated to one address space, job class, subsystem, or the whole system. RMF and SMF data help correlate utilization, service classes, dispatching, I/O, and timing. I compare the incident with historical baselines and check recent code, database, or schedule changes. A runaway loop, inefficient SQL, excessive sorting, or WLM misclassification may be responsible. I validate the fix with measured before and after results. Be sure to cover workload identification, SMF data, RMF reports, WLM service classes, dispatching priorities, address spaces, loops, I/O waits, recent deployments, and separating symptoms from root causes. Question 11. How do you troubleshoot a common mainframe abend such as S0C7 or SOC4? For SOC7, I suspect invalid numeric data, then inspect the dump, failing offset, program listing, and input record to identify the field. Copybook mismatches and unvalidated external data are common causes. S0C4 usually indicates an addressing or storage protection problem, so I examine the instruction, registers, pointers, and storage overlays. I reproduce safely, correct the underlying data or code defect, and add validation or tests to prevent recurrence. Explain what each abend indicates: dumps, offsets, compile listings, PSW, registers, data validation, copybook mismatches, protection violations, and a disciplined path from symptom to corrective action. Question 12. When would you choose batch processing versus online processing? I choose online processing when users need immediate responses, such as checking an account balance, and batch when large volumes can run on a schedule, such as nightly billing. Online systems optimize latency and concurrency, while batch optimizes throughput and predictable resource usage. Some solutions combine them. Transactions capture events online, then batch jobs aggregate or reconcile them later. The decision should consider service-level objectives, data freshness, failure recovery, and operational windows. Discuss workload timing, latency, volume, user interaction, resource utilization, consistency, scheduling, throughput, CICS transactions, and examples where splitting or combining patterns is appropriate. Question 13. How would you use IBM MQ in a mainframe integration design? IBM MQ decouples producers and consumers through queues, allowing mainframe applications to integrate reliably with distributed services. I use persistent messages when delivery must survive failures and coordinate message updates with application work through sync points where supported. Consumers should handle retries and possible duplicates, because practical delivery is often at least once. I also define dead letter handling, monitoring, correlation identifiers, and queue capacity limits. MQ reduces coupling but does not remove the need for idempotency. Cover queues, queue managers, persistent messages, sync points, transactions, ordering, duplicate delivery, dead letter queues, retry policies, monitoring, and integration with CICS or distributed applications. Question 14. What is a Parallel Sysplex, and why is it important? A Parallel Sysplex links multiple z/OS systems so workloads can share data and operate as a coordinated environment. Coupling facilities provide structures for locking, caching, and communication, while products such as DB2 can support data sharing. Workload balancing and failure isolation improve availability and enable maintenance with reduced disruption. The design still requires careful capacity planning, synchronized software levels, and monitoring of coupling facility performance and contention. Explain multiple z/OS systems, coupling facilities, shared data, workload balancing, continuous availability, data sharing, failure isolation, and operational considerations such as capacity and coordinated maintenance. Question 15. How would you design disaster recovery for a critical mainframe workload? I start by defining recovery point and recovery time objectives with business owners. Then I map application dependencies, including DB2, CICS, MQ, schedulers, security, networks, and external partners. Replication technology, backups, and an alternate site provide recovery options, but consistency must be validated across components. I document step-by-step runbooks, ownership, and escalation paths. Regular failover tests are essential because an untested recovery plan is only an assumption. In your answer, include RPO, RTO, replication, backups, alternate sites, application dependencies, runbooks, testing, data consistency, networking, security, and communication during a disaster. Question 16. How would you modernize a COBOL mainframe application without disrupting production? I would first inventory business rules, interfaces, data dependencies, batch windows, and operational risks. Rather than rewriting everything, I would expose stable COBOL capabilities through APIs or events, then gradually replace peripheral functions using a strangler approach. Automated regression tests, parallel runs, feature flags, and backward-compatible contracts reduce risk. Some core logic may remain on the mainframe when it is reliable and cost-effective. Modernization should improve agility without sacrificing control, security, or availability. Discuss assessment, strangler patterns, APIs, event integration, incremental releases, data ownership, regression testing, observability, backward compatibility, risk management, and when to retain versus replace core logic. Question 17. How do sort utilities improve mainframe batch performance? Mainframe sort utilities efficiently handle large volume ordering, filtering, merging, and joining without writing custom COBOL loops. DFSORT can use include, omit, outrec, and joinkeys to transform records, while iStool supports reporting and analysis. I review sort work allocation, record formats, and filtering early to reduce downstream volume. Utilities are often faster and easier to maintain than application code, but I still validate output formats, return codes, and restart behavior. Mention DFSORT or equivalent utilities, sorting and merging, include and omit filters, joinkeys, iStool, utility efficiency, temporary work datasets, and avoiding unnecessary application-level processing. Question 18. A critical overnight job failed before business opening. How would you respond? I would acknowledge the incident, identify business impact, and establish a clear incident owner and communication channel. I would inspect scheduler status, JCL output, abends, dependencies, resource availability, and recent changes while avoiding unsafe reruns. If a documented restart is available, I would validate inputs and execute it with operations approval. After service restoration, I would confirm downstream outputs, communicate status, and lead a blameless review covering root cause, detection, runbooks, and preventive actions. Focus on incident triage, impact assessment, logs, dependencies, abend analysis, safe recovery, stakeholder communication, escalation, change history, and a blameless post-incident improvement process. Question 19. How can automation improve Kyndryl mainframe operations? I use automation to make repeatable work consistent and auditable. Schedulers can manage dependencies, monitoring can detect abnormal jobs, and tools such as OSMF or Ansible can standardize provisioning and operational tasks. APIs enable integration with service management and cloud platforms. I begin with low-risk, high-volume activities, add approvals and rollback controls, and measure outcomes such as fewer manual errors and faster recovery. Automation should strengthen governance, not bypass it. Be sure to mention scheduling, monitoring, Ansible, OSMF, APIs, standardized runbooks, compliance evidence, self-service, alert reduction, change control, and safeguards against automating incorrect actions. Question 20. How would you approach taking ownership of a new Kyndryl mainframe client environment? I would begin with structured knowledge transfer and an inventory of applications, interfaces, schedules, datasets, subsystems, owners, and service-level agreements. I would review incident history, monitoring coverage, security controls, capacity, recovery plans, and undocumented dependencies. Then I would build a risk register and validate critical runbooks through shadowing and controlled exercises. I would communicate clearly with client stakeholders, stabilize operations first, and propose measured improvements backed by evidence. Cover knowledge transfer, architecture discovery, service-level agreements, application inventory, operational procedures, security, monitoring, risk register, stakeholder relationships, documentation, and early improvement opportunities. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.